Can you guys hear me all right? Cool. My name is Shaunessy Grant. I am here from NASA's Jet Propulsion Laboratory, and I'll be talking today about an innovative new project that we've been working on to help with accessibility in the clean rooms. I really appreciated that some of the talks in the past day or two have been focused on the perspective of those of us working in clean rooms. Hannah yesterday from Molnica gave a really good presentation on the gloves and how we're focusing on how we can make the jobs of our technicians or anybody who's working in the clean rooms a little bit easier. And then the presentation just before me was a really great lead-in because they focused on some of the challenges that those of us who work in clean rooms have with the garments. And I'll be focusing today on some projects and some things that we've been doing, particularly focused on accessibility, to make sure that those of us who are working in clean rooms who may have a disability or who may have an injury can still do our jobs as those things come up. So the topic that I'll be talking about today is a project that we've been working on to get crutches in clean rooms. And I'll talk a little bit about why standard commercial crutches don't really work in our clean room facilities, and the prototype and design that we've been working on that allows us to have a crutch in the clean room. So I'll give a little bit of a background and an introduction to why this is a thing that NASA is working on. I'll talk a little bit about how we do clean rooms at NASA's Jet Propulsion Laboratory. I'll use JPL as kind of an acronym for that because it's very different than a lot of the clean room systems that we've been talking about in this conference. I'll talk about accessibility and some of the challenges that we have and how we're addressing that. And then I'll go into the prototype that we've created, the design, the testing, the structural analysis that we've done. The next steps, as this is still very much in the prototype phase and where we want to go with it, appreciation of the larger team that I've been working with, and then I will open it up for questions. So a little bit about me. My name is Shaunessy Grant. Like I said, I work for NASA's Jet Propulsion Laboratory. I've been there for about 6 years. I'm currently a mechanical engineer and a contract manager, so I work very closely with our suppliers in managing the contracts that we have for when they deliver flight hardware to us. I started my career at JPL as a quality engineer, and prior to that, I had a lot of experience in manufacturing. I've been working in clean rooms since I was about 18. I had an internship at Apple during university, and I got to go to China and work in some of the factories there for a couple weeks, and that was my first exposure to how clean rooms work, and then moving into the aerospace industry, how the different focuses are in different industries. At NASA, I've worked on a number of different projects. I started off on the Europa Clipper program, which is actually launching this year. This is going to Jupiter and looking at its moon Europa because we believe there is a large ocean there, which could have the possibility of life. During COVID, NASA created a ventilator, and so I was the quality lead on that, which was a really cool and impactful project. I've worked on the Mars Sample Return Program, which I talked to a couple of you about yesterday, which is a really exciting thing that's coming up. And I'm currently working on the Crystal program, which is a satellite that's actually a conjunction with the European Space Agency, and we'll be looking at the polar ice caps. Throughout all of this, kind of on the side, in addition to my technical roles, I've been working with our Office of Inclusion as the diversity engineering liaison, focusing on accessibility. So the core team that I've been working with, Eleni Comstock has been our kind of primary investigator. I've been the project lead for the last year and a half. Tagui Arakelian, who some of you may know, she's our real clean room expert at JPL. And then Preston Brumley was the mechanical intern that really took this on this past year. So like I said, clean rooms pose many accessibility challenges. And just a quick overview of how we define accessibility is we want to make sure that people with disabilities have the same opportunities as those of us who are able-bodied without having to put in an extreme amount of effort. Most assistive technology and mobility aids cannot be used in clean rooms, whether that's due to the materials. One of the things that I'll talk about that came up in one of the questions in this previous presentation was electrostatic discharge. and how we need to make sure that we're not compromising our electronics. And there's not always space to put extra things in clean rooms. And so, as all of you guys know, many industries use clean rooms. According to Semiconductor Digest, we've got about 120,000 clean rooms around the world, which means there's a lot of people working on them, and we want to make sure that jobs and different career paths are available to as many people as possible, regardless of whether they have mobility restrictions. So our solution to this is to design and prototype mobility aids that can be used in clean rooms. At JPL, we have over 150 different clean room facilities. We've got about 144 acres of land, and these are everything from small, like micro device components, all the way up to our Europa Clipper is 5 meters tall and 30 meters wide. And so we've got these massive, massive spacecraft that we're putting together. And therefore, our clean room facilities can be anything from a tiny little contained system all the way up to our largest one is 900 meters square. So we've got a wide range of different clean rooms that we're working in, and we have a wide range of different ISO levels, depending on the projects that we're working on. One thing that we have to care about, in addition to typical clean rooms, is planetary protection. What this means is we want to make sure that when we're going to different celestial bodies, we're not contaminating them with human things or with elements that wouldn't naturally be present, whether that's going to Mars. We recently had a program that brought back samples of meteors, and we want to make sure both that going there, we're not going to contaminate the samples that we're bringing back, but in returning samples back to Earth, we want to make sure that we're not bringing back things and potentially contaminating the Earth, and we have to make sure that we're really containing how we go about analyzing these samples. So we have a whole different team. We have our contamination control team at JPL, but we also have our planetary protection team that's more focused on celestial bodies and how we protect us and how we protect them. And so because we have very many different projects that we're working on, each project has additional requirements. So we can't just say, oh, this Mars sample return program, we can go to an ISO level 5 clean room, and that's good enough. Each project has, within the ISO levels, we have different requirements that are kind of specified for the type of science that we'll be doing with those different instruments. So our clean room team is very, very busy, our facilities team, making sure that we're monitoring all these different 150 clean rooms to exactly what they need to be. And because we have so many projects, these clean rooms can have different requirements every year or two. And so we need to make sure that we're keeping things updated and changing things out with the projects as they come up. We do a lot of different monitoring, as a lot of people have talked about before. Remote continuous airborne particulate. We really care about humidity, particularly for electrostatic discharge. When the air gets really dry, we can't be working on electronics because it's very easy for somebody to shock something without even feeling it. So electrostatic discharge is like when you're walking across the carpet and then you touch a doorknob or another piece of metal, you can kind of feel that spark. Something like that can absolutely fry your electronics. And the level of sensitivity that we have is without even feeling something from yourself, you can fry the electronics. And so we do a lot of different measures to make sure that we are electrically grounded and not going to damage the things that we're working on. And humidity is a big part of that. We've got the differential pressure monitoring, and then a lot of different people at JPL really care about the results from this clean room monitoring. Project managers care, hardware quality assurance people care, our technicians care, and the cognizant engineers. Everybody is considered a customer for this clean room team. We have witness plates that a lot of people have talked about, and one of the fun things that I found really interesting in preparing this with Tagui is we've had to make kind of our own setups for these because, like I said, some of our hardware are 5 meters tall. Having a witness plate at the human level or on a table isn't really going to tell us what the environment is of the entire spacecraft. And so we have different stands, we have different things that we've used to adapt to our particular needs. We've got cleaning processes, material controls, continuous monitoring, and all of that good stuff. And so I was talking about ESD, or electrostatic discharge, and why it's a problem. There are not many materials that are both ESD safe and contamination control safe, which is why typical standard crutches don't fall into either of those categories. We've got material outgassing concerns, verification processes for anything that needs to come in the clean room. And then as far as the electrostatic discharge or ESD side of things, Southern California in particular can get very, very dry. I've been part of multiple stand-down days where we've said, hey, the humidity has dropped below 30%, we have to shut down work, or we have to use an ionizer. If we use an ionizer and it gets below 15% humidity, we have to shut down regardless. We've got some really warm, dry, windy days, and you can kind of tell from this picture, but we're in a giant canyon. And so that kind of exacerbates a lot of the climate issues that we're going to have. So moving over to accessibility a little bit, clean rooms are not known for their accessibility. I think the previous speakers were talking about how uncomfortable our clean room garments can be. There are trip hazards everywhere. I particularly have issues with putting the booties on and then tripping over the plastic at the bottom because it doesn't exactly fit my shoe. And there are a lot of different things that we have to keep in mind as we're working in clean rooms. This is a picture of Europa Clipper. This was just taken a couple weeks ago. But you have to climb upstairs. You're often, if you're a technician or a quality person, you're in very uncomfortable positions trying to lean over or look at different parts of the spacecraft. There are very confined spaces. We've got nowhere to store mobility aids. And it's very, very difficult to work in a clean room if you have mobility challenges. And so that's where our Clean Room Crutches project comes in. Majority of this work took place last summer. We had Preston Brumley from the University of Colorado come out and help us. And his main task was to design and prototype a crutch that could be used in a clean room. The main focuses that he had in this project were switching out the materials to make sure that we were using materials that wouldn't contaminate the clean rooms, making sure that we are taking into account the electrostatic discharge and so that we're not going to accidentally shock any of the sensitive electronics that we're working with, and making sure that it's structurally sound. Anything that's going to be carrying the weight of the human has to be able to carry it and be tested in ways so that we know that it's safe. So commercial crutches have a whole bunch of issues when it comes to clean rooms. The first kind of biggest one that I think is apparent to a lot of people is the foam on the underarms sheds like crazy. And so we obviously can't have particulates coming off of things that are in the clean rooms. There's a lot of pinch points if you're using gloves and trying to do any of the adjustments. This wing nut here is a place that's very easy to get your glove caught and not really know about it, which is where that double glove system would come in really handy. We've got holes which can trap debris and then let it back out into the clean room. Plastic joints, we don't want to use plastic because it outgasses, as well as the rubber at the tip of the crutch. These are also not electrically grounded, and so by using it, you could damage your hardware. So we made a whole list of design requirements as we were going through this design and prototype process. These were a combination of ISO standards as well as internal JPL safety standard documents. We needed to make sure that they were ESD compliant. We decided to try to implement these at an ISO 5 level, so we needed to make sure that they could be precision cleaned, that they were using clean room safe materials, no outgassing, no lubrication, and that we didn't want any of these materials to be carrying a static charge. We needed to make sure that they could withstand different sizes of people. So we have 2 different adjustment areas, and that it didn't compromise any of our garments or consumables. So the material selection was kind of the first thing that we went into. For the underarm and handle portion of the crutches, we researched a lot of different materials, and this ESD POM acetyl became clear that it was one of the only plastic-esque materials that was both clean room safe and that it was a closed cell material structure so that we could machine it and after it was machined, it didn't, have a cellular structure that could trap contaminants and then release them. And then for the tip of the crutches, we cut up a Cleanroom shoe. And so I brought, but left in my suitcase, the shoe that we actually cut up to make the tip of the crutch so that it would be both statically compliant and it's not going to slip around. And then for the structure of the crutches, we are using iodine-coated aluminum, and iodine is used to prevent further corrosion. So this is the crutch that we actually made. It is made from ESD and Cleanroom safe materials. There is no transferable lubricant, and it is able to be resized and assembled while using gloves and disassembled into parts for precision cleaning. So we've got the POM acetyl material that we've got for the underarm and for the handle. We've got a full aluminum body. This particular model was not iodine coated because it's our first prototype, but that's in the design for the next iterations. Down at the bottom, you can see there's no holes that would allow debris to get captured. We have an internal slide system where there's like, in crutches that you usually see, you can see 12, 15 holes on the outside. Those are all inside this aluminum sleeve. And then this point right here is a through hole that has a quick release pin so that you can figure out which hole aligns with the height that you need without having external holes that would trap things. And then we've got our little Cleanroom booty sole down here that we tape together with Kapton tape, which a lot of people in aerospace refer to as space tape because it's a very weird yellow color that you wouldn't expect tape to be. So this is the overall design of the prototype of the crutch that we made. Then we went into structural analysis to make sure that it was safe for humans to use. We based a lot of our load cases on ISO 1134-1 as well as our internal JPL safety documents. We did a lot of, this is a hand drawing of a free body diagram where we started anticipating the high points of stress and where we needed to do this analysis. And then we went into finite element analysis. We did a lot of CAD and kind of used the more computer side of things to make sure that it was really safe. We had two main load cases. People use crutches in different ways. I think the proper way to use crutches is actually to use the handles and put your weight on the handles rather than the underarm section. But because people use them both ways, we wanted to do load cases for each of those. So we have two different load cases where the force is applied at the underarm section, and then the second one is where the force is applied at the handle. And then we used ISO 1131-1, which calls for a distributed load of 500 newtons at an angle of 0 to 20 degrees, because as you're using crutches, some people use them here, some people use them out here, and we wanted to make sure that for most of the ways that people would use crutches, that we've made sure that these are safe. And then we did change the variables for the different forces that we could expect. We did cyclical analysis because you're not just putting the force on at one time. As you're stepping, you're doing loading and deloading, and then over the course of using them in a clean room for multiple years, we wanted to make sure that they were safe too, and we looked at the angles. So we set up the finite element analysis. The crutches were modeled with shell elements, hexahedral elements, and beam elements, and then the fasteners were modeled with RBE2 elements, which are pretty stiff, and C-bush elements, which allows for the extraction of forces. And then the tip and cushions, because we didn't want to show those as completely stiff because they are compliant materials, we modeled them with RBE3 elements, which still create that connection, but in a way that doesn't add stiffness to the model. So this is the free body diagram of the 20-degree load case where we're applying the force at the handle. We've got the fixed points at the bottom, and then we've shown how the forces are distributed throughout the body of the crutches. And this is one of the analyses that we got that I think is pretty cool. You can see on the, the left-hand side here that we've got a result, and then I'm not going to go into the numbers, but it shows where the stress is concentrated. And then we used that to make a design change. Because the stresses were not what we wanted them to be, we changed the diameter. This is for the fastener that goes all the way through the handles. And so you can see on this side, this fastener was a little bit thinner. This was a 6.4 millimeter fastener, I believe. And because of the stresses that we were seeing there, we realized that we needed to change the design to go to an 8.4 millimeter diameter, which showed a pretty significant decrease in the stress that we were seeing. So once we got that, we started going into the prototype design. We ordered a lot of materials off of McMaster-Carr because this was a prototype. We're not looking at the best and most cleanroom safe materials in this initial prototype. Those are part of the design as we get further in this project. We didn't assemble it in a cleanroom, we assembled it in one of our labs. But we got to put it together, see what things were working, see what things were not. We worked really closely with Tegui to come up with a list of things that in this next iteration we want to mitigate. And then because it was safe, it was clean, I actually brought it into a clean room that I was working in and did a little photo shoot, which was kind of fun. So the next steps for us, we're going to be doing some mechanical tests. So far, we have done testing on some of the materials. We've done particle shedding tests, outgassing tests, and electrostatic safe tests, specifically looking at those cleanroom booty shoes and making sure that as we cut them and form them into different shapes, we're not compromising the integrity of the materials so that we're not creating things that would be shed because we cut it. We are going to be doing more static and cyclic load testing. We did all of the analysis, but we actually have different tension machines and compression machines at JPL that we're going to be doing this testing on. And we're going to be looking into alternate materials to certify. Once we have done all of this, we do anticipate creating multiple sets that can be used across JPL cleanrooms. Our plan right now is to store them in the gowning area, so people can use their individual crutches as they come into the gowning area, get all suited up, and then use the crutches that will have never left the gowning area to get into the clean room. So these will stay in individual clean rooms, be cleaned before and after each use, so that we know that they're safe and can be used for anybody who needs them. We have submitted an application for a provisional patent, so this technology is patent pending. And at this point, we're looking for partners to help us manufacture and distribute these as we get closer to finalizing the end product. So this is the majority of the team that we've been working with. I mentioned Eleni, Preston, and Tegui. We also had Dr. Tora Maltese, who was our contamination control expert. Morgan Walker was a previous intern who focused on the research behind this, and she was the one that really figured out nothing exists commercially that can be used in clean rooms. Allison Yu was our structural analyst. Kayla Anderson was one of the people who first started this idea. She and Eleni realized that, hey, you know, if I break my leg or if I have a continuous disability, I can't do my job, and that's a problem. And then Talia, Neela, and Jason were our management team who really gave us the funds and opportunities to do something like this. I also wanted to thank the HPCIM media team who gave me the opportunity to do this talk. Working with NASA can be very, very difficult, and dealing with all of our restrictions right now about what conferences we can go to, what things we can say. I really appreciate the efforts that they did to get me here. And thank you to all of you guys for being interested in listening to this.
Thank you, Shaunessy. That was really good. That was really good. Thank you very much.
Yeah.
Got questions for Shaunessy? Yeah, hand come up straight away. Look at that. There you go.
One of the issues with not having a crutch available before is because the people with physical disabilities, whether through injury or other means, have difficulty in actually donning the clean room garb appropriately and you know, to be accredited or to meet the accreditations consistently. So how do you manage that?
I have a picture that I meant to talk about, I think, somewhere back here. Yeah, so putting on the gowns is very difficult. Because this is kind of a new area that JPL and NASA in general have been looking into with accessibility and inclusion. This isn't going to be like a one-size-fits-all, everybody can now work in clean rooms. This is kind of the first step. We do have a number of ideas about things to do next, where I think our next project is going to be working on wheelchairs. But we definitely are thinking about how can we make gowning up easier. Like you said, it's very difficult. And at JPL, we've got the booties, we've got the whole coveralls, we've got the hood, we've got our ESD straps, which can get in the way of things. So there's definitely a lot of work to go to make sure that we're continuing this pattern of making things more accessible. Thank you. Exactly. Or if you're young and dumb like me and get injured all the time, also a problem.
Any more
Other
questions? Yeah.
Maybe just extending that to garment design. As we have to work till we're 75, are you thinking about how loss of mobility, how we get into garments? You're looking at radical redesigns of garments so you can don them effectively?
Yeah, I am not a garment design expert. I think some of the other people in this room who make garments would be a better person to pose those questions to. But I think that is definitely something that we should be thinking of as I think everybody is reaching the goal of reaching more customers, making things easier for different groups of people to have careers in areas that may not have previously been available to them. So I think that train of thought is definitely something that we want to be talking about and moving forward. So one of the things that I do want people to take away from this presentation is, even if you're not somebody who's affected by a physical disability, or you don't need crutches in your clean rooms, or this isn't something that's directly applicable to you, I do want everybody to think about how you can expand accessibility in the areas that you do work in, because clearly this is something that does affect a lot of people and may not have necessarily been thought about previously, but is something that we can do, because increasing accessibility for one person who has a mobility issue can be applicable and beneficial to everybody else. Like you said, as people get older, we have different mobility needs. If I break my ankle when I'm running, I have different mobility aids. And so doing something like this and really progressing with accessibility and inclusion in general is really a big win for everybody, not just individuals who struggle with this.
Thank you. Any more? Yeah, another question?
Hi, Shaunessy. We spoke yesterday about bringing samples back from Mars and contaminating different planets. But because the conference is talking about risk assessments, how do you, so when I'm doing a risk assessment, if it's improbable or it's a highly rare event, it's dismissed, but how do you guys discuss things that are not even in, possibility, but you still have to entertain it? How do you go about that?
Yeah, so that's a great question. As I mentioned, I was a quality engineer for a little bit, and so that was part of my job. We have an entire organization dedicated to risk assessment. So we have our quality engineers, we have mission assurance managers, and we have discussions about this. We have different matrices for different risks that we may have, whether it's, someone accidentally creating a charge in a clean room and potentially frying electronics, all the way to how do we make sure we're not contaminating Earth with something that we're bringing back from Mars that we didn't realize was there. And so there are a lot of huge meetings at levels way over my head about how do we make sure that we're thinking about all of these things. And we have experts from all over the world who give us our inputs and just make sure that we're not overlooking something, because NASA and the European Space Agency and anybody who's in the aerospace industry is really doing things that humans have never done before. And so, one, we're going to mess up. There are going to be things that we don't realize that we overlooked the first time that we need to integrate into future missions. But we do make sure that we're collaborating with as many people as possible to address these things.
Any more questions?
Great.
Excellent.
If
Thank
people
you very
have
much.
questions about NASA in general or accessibility or how you can help us move forward with this, I'll be around the rest of today and then after the conference and tomorrow as well. Thank you.
Okay, thank you, Shaunessy.